right, so a couple things we're going to go over here. Broad sweeping strokes here, importing options and types. All right. We're going to look at, once we get that in, some of the best practices for validating and repairing geometry. And then we'll introduce a few of the commands, or talk about a few of the commands with editing and manipulating imported geometry. This is heavily based in surfacing. Okay, it's really awesome if we get solids every single time that we import something in, but that's not always the case, and it really kind of depends on the export option of the person sending it from some other CAD system, CATIA, Unigraphics, etc. Okay, with that, so we'll talk a little bit about that. So I'm going to be kind of swapping back and forth here between my slide a little bit here and in SolidWorks. Okay, so let's take a look here. Importing options and types, specifically types here in this particular graphic. We've got a ton of them, okay, that we can import. We actually have some folks that use SolidWorks as a translator for the most part, and occasionally use it as a modeler. We've got a lot in here that we can push in and out. Okay. Common file types here: STEP, IGES, Parasolid. Okay, others here that we're going to talk a little bit about here is FTL, ACIS, ACES as I call it, DWG, DXF. Kind of depends on who you happen to be working with. Okay, so let's start talking about some of these here. So let me go ahead and make sure I'm sharing SolidWorks here. And let me turn my PowerPoint off here. There we go. Okay. So we've got, when we go to open something up, open, okay, and we can go in here, and again, here's that graphic from that night school that we just talked about. Oh, I'm sorry, before I go any farther, if for some particular reason my sound quality of my phone does something strange, starts to degrade or whatnot, please go ahead and you can go ahead at that point, just let me know if that's happening, and then I can switch over. Half these, for some particular reason, I think it's just traffic this time of the night, for some particular reason, things start to slow down a little bit. So let me know if that does, and I'll switch immediately over to my cell phone. Just a little harder sometimes to kind of do it no-handed, so or one-handed. Okay, so let's take a look at this. So common ones here. The one I first want to talk about is Parasolid, and the reason I like Parasolid here is the fact that this is the kernel, or it's kind of like the engine that SolidWorks is built on. Okay, when we import out of something else and into SolidWorks, so for instance, coming out of, say, SolidWorks 2013 and sending it to a SolidWorks 2012, we're going to get our best chance of a clean translation with a Parasolid. Now, there's listing here of opening a bunch of different styles there of Parasolid. Okay, but if we have a file here and I do a file save as, okay, and I change this, we really have here a Parasolid X_T and an X_B. Okay, X_T, that's the one you want to use. The X_B sometimes goes to specific systems. It translates it a little bit differently. So the X_T is that better option, okay, to push from. So Parasolid first, if possible. Okay. Next up would be STEP. Okay. Now, when we import in, okay, and I take a look here, and we see STEP. It's 203, 214. Those are the two main file types. Now, there's all sorts of different STEP versions, and I've actually had SolidWorks import other things besides these two particular versions. But for the most part, in a CAD system, they're all very specific to particular programs, types of files that you push in and out. But in our case here, 203, 214, when we pull it in. Now, there are options associated with these when we pull them in. We'll get to that here in just a second. So I know this is dealing with imported geometry, but I also like to throw in here talking about exporting things as well. So if I have this particular solid here behind me and I want to push this out, I'm going to take here and I have that option of a 203 or 214. This is usually the easiest way I remember it. Think of 203 as your solids, okay, and 214 is an everything file. Solids, surfaces, 3D sketch geometry, you can throw everything. Now, good design practice in your files when you're pushing things out is when you're done, you don't have any kind of, at least you're down to the bare minimum of bodies that you need. SolidWorks will ask you if you would like to resolve hidden bodies, okay? And if you're just blasting through the yes to get it going, you might miss that. And then all of a sudden what you do is you send more things than you really need to send, start sending construction geometry. Now the person on the other hand has to do some potential, what is this? Do I need this particular surface? The famous one that I work with, or worked with, I should say, is, this would have been 6 years ago, was doing, working for a company in Dearborn, Michigan that did prototype material handling work. And then one of the last big projects I worked on was a rack that would hold ram bumpers that would go from, from the manufacturer down to the floor line to get installed on the truck. And when I would get data from SolidWorks, or from, Chrysler, they were using CATIA, and the problem was stock CATIA doesn't come with any exporting translators other than IGES. And in this particular case, the gentleman that I happened to be working with apparently didn't know that, again, there might have been other ones he had available, but he told me all he could do was IGES. And IGES works really well for solids, not sometimes the best for surfaces. And I'm talking big, complex stuff, not necessarily simpler items with it there. So when he would send this particular file to me, it always would contain a whole bunch of extra stuff. Now, we're going to talk about what we want to do with that extra stuff here in just a little bit here. But if I want to push out, again, solids, 203, surfaces, I usually do a 214. All right, so that would be the next. So parasolid, then steps. Okay, third in line here is IGES. Now, the only issue with IGES, it's a fairly decent translator. The problem is it stopped being developed in the late 90s. Okay, so because of that, sometimes we might not get the best of translations, especially more complex surfaces. Okay. Now, between those three, if we're working with, or you're working with a particular company that's using a different CAD system than yours, or you're working for them as far as design and they're sending you these, my best recommendation for you is to have them send every format that they can of these three: parasolid, IGES, or step. A lot of, depending on what your CAD system is, they're working with, may not have a parasolid translator, but you're pretty much going to have an IGES and a step. Again, unless you're dealing with stock CATIA, and they didn't buy the translator with it, and that's all they have is IGES. So now that may have changed. I should probably check into that, but that was the last time that I looked at stock version of it. All right, so if they can, send 2 or 3 of these. And the guarantee, two things that are happening here. On the other end, they're doing a file save as, right, to push this. So they can kind of see, are they kind of sending the right part? Okay. The other thing is, sometimes, more often than not, step comes in a little bit better than IGES, but sometimes it's the other way around, and IGES imports better than step. So if you're importing something, say you're importing a model and you're a mold designer, we'd rather not deal with bad geometry as much as possible. So maybe one comes in better than the other one, and instead of getting one and going, hey, this didn't import all that well, can you send me the other one, and wait, and then finally get it over to you. Okay, if you're dealing with an automotive company, that can be a long time because sometimes they don't let data out all that well to get it back to you. So speed is of the essence here. So this just helps you if you request that up front. It's going to help you there move a little bit faster there. Okay, so step, I just parasolid here. Now, there are options in here. If I click on any one of those, I get an options button down here that I can click on and change these. So here's I just here. Okay, what can we do here? Bonded surfaces. Again, there's all sorts of options here. Even beyond as far as some of the stuff that I'm familiar with, there's some options in here where you can try to import some of these. It just, again, it depends on your specific niche, what you happen to be working in. Okay, we got our step here. All right, when we import a step, solid surface geometry. This happened a while ago. Somebody asked me, hey, can you try to import this step? I knew there was something in it. There was about 700 kilobyte file. So there was something in there. But every time I try to import it in stock options, what would happen is nothing would appear. So I went here into my options and just kind of smacked myself in the forehead and realized, oh, hey, we can try this as a wireframe. And it turned out it was a bunch of 3D sketch geometry for a wireframe. Okay, there was actually no solid or surface geometry in this case. Now, that allowed me to actually build a surface model from that particular geometry. Again, sometimes you know what you want, but sometimes the person on the other end who's exporting doesn't or has never been in your position to realize the options that they can push out could make your life easier. So sometimes you might have to work on them, you know, if you're familiar with their particular system or familiar with their options, to ask them to try to change some options to allow you to get a better import. All right, so here, again, I just step here, and our parasolid here, we can output as different versions if we want. In this case, we go to 24 by default. Again, if that other person you're pushing to requests a specific version, we can change it. Okay. So also here, flatten assembly hierarchy. Okay, you can take something during export and essentially get rid of subassemblies, okay, if you want there. Okay, so next up, after these kind of more common imports here, we have some other ones that we might deal with. And for instance, one of them here being STL. Usually STL here is used as a file format to push to like a 3D printer. All right. That's the most common one that I know of anyways, that I work with an STL format there. When we push that out, I'm sure some of you, I'll try to do one here in a little bit. It breaks that faces down into what looks like a bunch of triangles. It almost resembles a meshing in a simulation. And what you can do with that then, like I said, send it to a 3D printer, it analyzes it, and then goes ahead and prints it out. So STL as far as either pushing it in or bringing it in. Okay, so let's see here. Let's go to an open. Change my option here to an STL. Okay, so import as. Here's another one. Okay, that when you're opening these things up, I think I've changed it here, but I believe the regular import here is a graphics body. And this is literally only visual. Okay? It's you can't select anything. You really can't do anything with it. It's literally there just as a body. But if the other person who's pushed this STL here allowed it, we can try to bring it in as a solid body, bring it in as a surface body, and we can specify our units as far as what we want to bring it in as. Okay? So you may find, for instance, that it's scaled differently. So we can tweak that a bit there, change your units up. All right, so STL. Now, ACES. This is for the folks that are working with people that are still on any kind of, like an AutoCAD. Okay, with AutoCAD, you can take, say, for instance, this particular solid here. and do a file save as, and I can push this to an ACES file. What it'll do is it'll create a giant wireframe, okay, with it there. But they can import it, okay, and they can bring it into their AutoCAD if they need to see it. I think there's better ways for them to evaluate solids like e-drawings and things like that, but it's doable. Okay, so again, a file save as, and change this over here again to a .sat file, okay, or ACES. All right, the other one here, DWG DXF. Okay, with that, okay, we can do a lot of stuff with this. Well, mainly here, two real big things that we might do with it. We might take here and open a DWG file up and import it into, say, literally a drawing file. Okay, so when we say file open, we can say, hey, bring this in as a drawing, and what you can do with it then is to see it here, your DWG, all of its entities pushed over to SolidWorks entities. So for instance here we could have, again, we can draw just like, again, that, but I could say, well, here's a front view, here's a right view, just an example of what it might, again, look like. So maybe a hole here, and then I'll have some construction lines. So again, it's just going to import. There we go. Okay, and looks something like this. So if this was my 3-view, again, DWG or DXF, okay, we could, again, take advantage of that and import it. Okay, and that's great for if I just need to have legacy 2D stuff pushed into, pushed into DWG. I don't need a, sorry, I was just reading a message here. I don't need to have a 2D, if I don't need a 3D solid, I don't necessarily have to go through that. If I've already got a 2D drawing that's accurate, I don't anticipate editing it. It's legacy data. It's on components that we're not going to do. It's purchase components that we're not going to change. We may not need to go through the effort and time and money to do that. We can just bring that in as a solid. Okay. To have all parts, files associated. Corey, I'll have to think about that one here for a second. So, anyways, so with this here, okay, we can pull in that DWG or DXF. Now, on the other hand here, I'll just do this one. Let me do a save as, and I'll save this out here to a, say, a DXF here. Okay. And when I can open, again, I can literally open this up, again, and just see it just as is. Just thinking about it here. Okay. Now, let's take here, and when I open here, I'll change it to all files, and I'll find my DXF here. And open. And when I open this, I get an option here. Again, here's create the SolidWorks drawing. Okay, so that way, again, I can import that in with the border and all that kind of good stuff and just use the stock B-size piece of paper or whatever size it happens to be. You can actually embed this thing in order to link it to the original. So I can still just use SolidWorks to open it, but then it will, again, it will show it, and it's basically parametric at that point. You can link it to that original file if you want to. Again, there's multiple scenarios of why or why not you might want to do that. Okay, the next one here I want to show is importing this as a new part. So in this case, this is just a 2D sketch here, and I can go through the effort here of, okay, I want to bring everything as is. And I can bring it in as a sketch. Now, the handy thing here would be, now there are, and it popped up here, 2D to 3D, kind of a little program that can help you out with our little macros here to help you out with kind of creating your three views out of this. At a minimum, you could come in here and use this and get rid of things that you don't want. Okay. And then reuse this sketch to do, again, extrusions, however long that I want. I can use the command like the tools, dimensions, and fully define in order to throw some dimensions on there, and just reuse these sketches to do all sorts of stuff as far as creating. In this case, pretty simple here. It's just a matter of, okay, how long is this, and just extrude this particular area using maybe a select contours here. Okay, and then just identify it by a particular length of whatever you happen to measure this that vertical distance at. Okay, and once you plug that in, all right, okay, and we've got ourselves a part. Okay, with that. So DXF DWG is a common thing that I see still living in Southeast Michigan. Still a lot of small industry going around. A whole lot, and actually growing again. But a lot of places, small places, they're still using, that 2D program to work with. Okay, and they haven't jumped into that 3D yet. So we can get drawings from them or push things out to them. Okay, now, best practice here. So basically, big bullet point number 2 here. Best practice for validating and importing geometry. Now, when we import something in, now I'm going to close everything here. Okay. If we were to leave SolidWorks, and this is my favorite way to bring things in, okay, if we leave SolidWorks open and I just go ahead and drag and drop into the background, what this is going to do is use whatever you have set up for your stock part template. Okay. We'll get to this import diagnostics here in just a second. Okay, now I just want to show you what I just did is essentially the same thing, okay, as me opening a particular template that I want. Okay, in my case, the part millimeter is the stock template. Okay, so when I drug that into the background, that's the particular template it used. We can see that through my options under default templates. There we go. Okay, using this particular millimeter part template. Now, if I have one open, say part inch, and thinking, there we go. Okay, if I take here now and do the same thing, drag and drop into the template here. This is the same exact thing as what I just did, except I picked the template. For the longest time, I didn't realize you could do that. But in either case, I like drag and dropping out. Reason being is every time I go to open, generally speaking, this might be sitting on SolidWorks files. Now I got to remember, okay, was that a step? No, was that an IGES? Because the work that I worked in, we could have got almost anything. Okay, so I like to try to just push it right out of my File Explorer here. Just made my life a little easier. Didn't matter what it was, just drag and drop with it. Now, when I bring files in, notice, and I don't know if you caught it there, if I bring files in this way, import diagnostics did not turn on. That warning to say, hey, do you want to run import diagnostic? That is the one advantage of letting this happen. Otherwise, we got to remember, hey, we should use this, because you should always use that tool called import diagnostics. Okay, what is it? What it does is evaluate this solid when you import it in to make sure there's no errors in these faces or weird things going on with these faces. Okay, so I'm going to take here, right-click on the first, what it shows as a body here underneath origin in my tree, and do an import diagnostics on it. Okay, now in this particular case here, if I click on it, there's something weird with this face. Now, it's not quite Windows-esque, some 25-character string of gobbledygook. You have no idea what's wrong. This one's more straight to the point. If you right-click and say what's wrong, general geometry problem. What does that mean? It could mean a lot of things, but here's my rules that I have when I'm importing things. In general, for this, like something fairly simple like this, I'm going to take here, if I can fit, or it fits, everything that's wrong with this particular file within the window, as in there's no scroll bar on the side here, I'm going to pick on the attempt to heal all. Okay? And in this particular case, it fixed it. Okay? It fixed that particular potential issue. Now, we'll talk about what those issues might be here in just a moment. Okay? But once it's there, I'm good to go. I save it. Okay? And I've got a nice, clean part to now work on to do whatever I happen to need to do, okay, with it. Now, other tools that we have available to us to kind of evaluate curvature. Okay? This is especially when we get into parts with a lot of fillets, specifically things with that are C2 curvature or curvature continuous. Getting closer, not just a straight fillet, but in SolidWorks world, sometimes kind of in between just a stock fillet and, say, Class A surface. That's the term most people are familiar with, outside of an auto body. Okay? There is no transition in between, seen between a flat and an arc. Okay? None whatsoever. Even on, say, like the new Cadillacs that are fairly sharp in corners, if you look real close, you can't tell where one curve starts and where the other one ends, and that's that blending of those particular surfaces. Okay, now curvature. This is going to help us here in just a little bit. I'm going to import a couple of things here. I want to take a look at it. Okay, so under the Evaluate tab, we have something here called Curvature. Now, I take a look at this. Anything that's black here, and if I hover my mouse over it, shows a curvature of 0. It's flat. Okay. Anything here that has a stock solid color here, notice here we've got a radius of curvature, some weird metric number there, 3.3375. Actually here, if I turn my units here to inch, still a strange number with that. Okay, but the point is, look at the color of these things. They're all solid, okay, for the most part, until we get into some of these things right here where we see a fade. Anytime we see a fade like this, we're getting a different type of fillet here. We're not getting this a C1 fillet, which is tangency, okay, where it's the same curvature across the entire fillet. It varies throughout. Okay, so if I take a look here and I go down, I start up here tight at 0.14 and work down, and I get down to here, and it's really hard to see on that orange background, but 0.15. Okay, so it's varying here with that. And it's not necessarily there's something wrong with that. It depends on how the other person on the CAD system imported it. All right, so let's take a look at another one here. So let's bring this knife in here. Okay, do you want to run import diagnostics? Yes. I want to take a look. Now, this particular one we saw here, it imported as a multi-body. Okay, in this particular case, this was a step file. Okay, and in this particular one, there's only one face that's wrong with it. And again, it's a fairly simple face. Okay, so I'm going to take here, and I'll do a repair on this one. It's the only one. I'll hit OK. It's set. Okay, now at this point, do I want to take this as a multi-body part and save these bodies out? That way I can work on them individually. Again, whatever you want to do beyond this particular point. Okay, another one. Okay, we might have something like this. Again, this one here is an IGES file, so I'm just going to bring in the IGES here. Again, do you want to run import diagnostics? Now, this one showed a definite error here, the yellow triangle. Okay, so sometimes you can get away without doing anything with it. It really kind of depends on what the end goal is. Are you just using this as a placeholder in a big assembly? I may not have to do anything to it. I don't have to go do fixing things because, again, it's there as just say a blob to avoid or something like that. We're not necessarily working on it directly. I'm still going to run it because even if I don't fix things, I still think you should at least see what might be wrong. Okay, so I'm going to take a look here. And this one has a few more errors in it. Now, when I start stacking the errors up, generally speaking, what I might do here is start looking here as I pick it. I can see it. And the problem is it's actually on the inside of this thing. Okay, besides this one little face here, as far as what might be wrong. Now, what you can do with this, I'm going to escape out of here just for a moment before I finish that. And I can turn on, now that I know kind of the area, take advantage of using section view here. Okay, so you can take and I can bring this pretty far up here. Okay, now that I've done that, I'll still run the import diagnostics again. Okay, and now I can say, well, I'll right click. Maybe I can't find it. Right click, zoom to selection, and it will move and zoom you way up. Okay, you're still going to have to move out, but something here now, something with this fillet here. Notice how it's all kind of squashed in. Okay, now I'm going to try to fix this thing with an attempt to heal all. Now, what's cool about attempt to heal all is an algorithm that runs. So if it does not work the first time, you can click that button again to try to fix it a second time. It may run through. It's like, you know, a lawnmower in wet grass. Well, the first pass gets a good chunk of it, but we can go over it again because some of that grass dries out a little bit and stands back up. Okay, kind of thing here. So let's do an attempt to heal all. Okay. Sometimes it takes a while. Other times it happens quick. Okay. If you have more than what is available, as far as again, that slider bar, then I start being more picky about how I'm repairing. Clicking on individual faces, repair. Clicking on individual faces and repair. Okay. Sometimes this is a quick process. Other times, depending on how it comes in, man, I had one. This guy had, oh boy, 300 some odd faces that were bad and that needed work. And in that particular case, it was actually the guy pushing it out when this file save as. There were things that that person could have done that would have fixed that. But unfortunately, the way sometimes through suppliers and how A, B, C, and A goes to B, B contracts to C, and sometimes C can't talk to A. Okay, so again, sometimes it's not just easy to make a phone call and say, "Hey, send me another one." Okay, with it, but he had to do again just a bunch of work here. So obviously, I just talked about faces. So the more faces there are on a model, generally speaking, is going to take longer to import. Okay. Some of the things that you can do to kind of help your machine along, don't be streaming music, don't be streaming other music, working on other things. Let your machine run the fastest it can go. Okay, with that. Question, for sheet metal components, is there a way to bring in intelligently and then change bend radius? Well, yes. There's a little bit of work sometimes involved with of making that happen. Again, we can't. When you import, say, a sheet metal from some other, say an Inventor or something like that, it doesn't sit there and look at the tree as far as how that other program built it. Technically speaking, what happens is you're picking faces and surfaces in order to import that. So you pick a face during a sheet metal import that is the stationary face, and then you're picking bends and things. And what it's doing, again, it's ignoring the thickness of that imported model and replacing it with whatever you choose to be the gauge, okay, or type in whatever that, say an 1/8 inch gauge, okay, to bring it in. So during the process of that import, you are technically re-adding intelligence to an imported dumb solid, And at that particular point in time, then, as you're picking those particular, the bend radius and things like that, now I get to the question here, is it yes or no? I'm 90% sure that we could do that, okay? Because it's going to regard it, that bend, it's going to make it intelligent, and then that particular bend can be modified if we want. So it's a feature at that particular point. So pretty darn sure there. Okay, so a little off track there, but very good question. Okay, from sheet metal aspect. Okay, back to this. So I've imported all, worked great, everything's cool. Okay, one thing I might do here just to end, this is just something SolidWorks does afterward, is it gets rid of, whenever you import something, it gets rid of shaded with edges here. But you can always afterward, even though the import was fine, you can evaluate your curvature just to take a look. Okay, now this little hole that's appearing here, that's a graphics issue on my machine. But sometimes you get some blips like this. Now in this particular case, everything imported fine. Okay, if I'm going to actually go, this might be injection blow molded. So really, is that really hurting anything? Not really. I'm going to make a mold out of this thing, and that interior surface is going to depend on the air pressure as it comes in, okay, with it. All right, now let's take a look here at another one. Okay, with this this base frame here. Okay, now some of these, just to give credit where credit is due, some of these particular models are based out of some of the things that are from the book. Half these I got from, if you go to grabcad.com, I just searched for random step and IGES files that would work, as examples here. I think I've got something going here. There we go. Weird. All right. All right. So sometimes when we bring things in, okay, we just can't fix everything with that attempt to heal all. Okay. Now, before I go any further here, I'm just going to hit no for just a moment. Okay. There may be other times here, and this is on one of my slides here. I want to make sure I point this out. If we bring in an object that is symmetric, so for instance here, and let's go here. There we go. Okay, and say we're going to do some work on this. Okay, and we're going to take a look at actually this here, something called blended corners here in just a little bit. Okay, so we bring something in. What my goal is to take this area right here, okay, that looks, when the shaded with edges is turned off, just doesn't look that great. When aesthetics start to become very important, okay, this is where we might look at this, and it looks like someone just kind of molded this with clay, and I'm not quite sure how good that's coming over on your screen there. But it's very obvious that it's almost like someone just kind of molded some clay down. Now, we look at the one on the left here. Okay, let me turn on the edges for this for a moment. Okay, and we can see here with this blends nice and smooth. Okay, and again, the finished product just looks a bit nicer with there. Again, this is an aesthetics thing. This is another thing. How much do we want to repair, or how much do we want to modify? Is this going to be used on some component that's going in a machine that we're never going to see again? I'm going to throw just tangent fillets because it's the easiest thing to apply. Is this going to be something that's going to go in, something on a dashboard of an expensive car, expensive artistic-looking piece? Depending on whatever you have to be modeling, aesthetics might be very important. So in that particular case, that is very important how these blends look. Now, to go from this to this, you can see the difference in the tree here. So here's where our model on the right stops. Okay, and then I add all these items in order to get over, again, from here into looking smooth. So there's a fair bit of work that goes into that, but the finished product is that much nicer. Okay, so again, depends on what we happen to be working on. In this particular case, this part is symmetric left to right. So instead of repairing both these edges, say here and here, okay, what I'm going to do is just cut this part in half, okay, and I'll do that with a surface cut, repair one side, and then do a mirror on that body to bring it back over. Again, if it's symmetric, take advantage of it. Don't do twice the work. Just fix one side and then mirror things. Okay, so with that being said here, let's get back to this base frame here. Okay, I'm going to take a look here. Now, let me run that import diagnostics. Okay, in this case here, oh, look at that. We've got 3 faces here. Again, I can click on these faces and look at them and think, okay, this one's not too bad. That one's not, again, just a corner fillet, no big deal there. Okay, with this. Now, what I can do here, I'm going to do an attempt to heal all because, again, everything that's in here fits, no scroll bar. I'm going to run it once. Okay, it's going to think about it. Cool, it repaired 2 out of the 3. Now I'm going to try to click it again to attempt to heal all. Okay, and it didn't do it. Okay, you can click it 2 or 3 times. Okay, just to double check. Again, if it saves you time and effort, it's worth it to click it one more time to see if that algorithm will run. And what we're going to find here is no matter what we do, we're going to always end up with this face. Basically, there's something wrong. Okay, so notice here there's no error that shows up though. Okay, so what is really wrong with it? Okay, and we're going to see that here now. So at this particular point, again, how much repair do we really need? Well, it might be that if we're going to say, for instance, we're going to CNC a mold for this thing, you could probably try to import it in and do the tolerance of your CAM machine when it runs a toolpath around this. It may be just fine, and that what we're going to see what's wrong with this doesn't matter a big bit, okay? Because, again, do we really need to go through it? Your time is money, okay, with that. So let's take a look. Here's the secret weapon to figure out what's wrong, okay, on here. So I already showed it to you once. I'm going to turn on curvature. This is the biggest thing to help me out, to let me know what might be going wrong with this and why maybe the repairs aren't working all that well. Okay, now if I zoom in here close enough, I do, just hang on a second, I occasionally do a little bit zooming in here. Okay, notice here, I'm going to hold my mouse over here, and again, it's a purple background with an orange here. The radius of curvature on this one is 3. I come up to this top one, radius of curvature is 2.8. So I'm noticing that, again, they're slightly different. Okay, now I come over to this one on the left, it's 2.8, but as I move around, notice that number is varying. Okay, and when I get close up here to this edge, notice that that blue color is blending into this particular surface. Okay, same thing down here. I got this black blending in. Okay, to it. Also here, what's obvious, this giant blotch on here. And again, depending on where I go, radius of curvature 381. That's a really flat spot compared to the 3 out here. Okay, so number one, I can see kind of where the issue is with this face. But here, when we analyze things, faces around it, we look at that and see, oh, we're getting bleed through with these colors. These are supposed to be in this particular corner, tangencies. We shouldn't be getting this. And the fact that as I drag along here that I'm getting variances in that number lets me know that this particular face also is bad. So although it didn't show up on import diagnostics, this is another root problem as to why this is not working. Okay, so we may need to, in this case, I'm not going to go because I don't have time to go through this entire thing. We may need to do things where, okay, in this particular case, now this is straight out of the surfacing manual as far as in this particular case is a great example. Okay, this is where, think of it like that gross flesh-eating disease thing. What do? Well, they clean out the, take away the bad tissue and leave the good tissue. And it's the same thing here. What I'm going to do here is I would rebuild this fillet corner. Okay, so I'd use surface tools where I do some offsetting here. And again, I'm going to go through this not completely here. Okay, so I've done some offset with some surfaces there. Now I'm going to go ahead and delete. Okay, here. And what I'm going to end up with then is the leftovers. And let me just color this so it'll make it a little easier to see. Okay, of this gray. And what I would do, again, what I'm doing here is I would technically take here, I'd rebuild this corner. Rebuild those corners so it'd be all nice and square with some commands like extend surface. Then I would take here and trim this to a solid corner. And after I trim that to a solid corner, then I would re-add my fillets, knit it all together, and try to turn it into a solid. And in the case of the book, and in this case of this particular instance where we're finding issues with the fillets around it, that's the only way in this particular case it can be fixed. So sometimes we can't just be that one face. Sometimes we got to kind of start around it and work our way back into the middle. Okay, with that. So various surfacing commands again to use it. Okay, now let's look at some other ones here. All right, so let's see here. Here is an example of one that I did here. Let me turn the background different color here. There we go. Okay, where this might be a boundary around, again, if you try to imagine it looking at from the top here, that there is something around this, and we're either patching a hole or we're filling it in. Okay, and it's just to show, again, if we have some hole or something we need to modify, we can use sketches in order to basically kind of fill it in. Now, if I take a look here, let me do my original sketch. Now, this green one here, this is using what we call a boundary surface. Okay, and when we look at a boundary surface, it's really easy to identify if I look right from the top. Boundary surfaces require some basically direction one, or in our case here, vertical lines. Okay, in this case, they're splines, but it's just vertical sketch geometry. And then we might have some purple horizontal geometry. And what's interesting about this is the fact that this is done with no edges. Okay, this is just done here. These basically SolidWorks is propagating that edge out based on these intermediary profiles. Okay, so kind of cool. Now the other thing here would be, well, I can use these, but also what if I had an edge around it? Okay, now these outside edges become that boundary of this, but then we add in these purple and red ones here as essentially constraint curves or guide curves, depending on the command that you're using. Okay, to control and manipulate where that particular surface is in space. Again, so again, a little bit more repair thought if I bring something in and something doesn't appear. Now, that leads me to why would we have issues, or what kind of issues occur? Well, sometimes we get those issues right here where you get what they call face edge abnormalities. Okay, where something just is not jiving all that well. Okay, and we get something like this, a face edge abnormality with it. Okay, sometimes think of it like a rip in your sleeve. Okay, where it's knit together, and from wear or tear, it looks like somebody just yanked up, and there's like, it almost looks like there's too much material sitting there. Okay, where it kind of ripples up. We might get some of those things. That import diagnostics can help that. Other times we might need to just literally just rebuild it. Okay, kind of like we did here. Okay, or would do. Anyways, let me actually call up the corrected version of that. Now we take a look at here. Look at this corner now. Again, it was a 2.8, 2.8, a 3. And if I take a look compared to this corner, here's the original. We can start to see here. This corner was kind of just doomed from the start. Okay, just didn't blend. Also notice here as I kind of move this here, notice how the reflection is not quite as smooth through here. That's another giveaway. If your machine can do, curvature is one method. Taking and applying a shiny finish, turning on your real view, and if you don't get, if that reflection on there doesn't blend nicely as you're kind of rotating it around, that's another giveaway that there's something wrong. If I look in here, and you can kind of see it with that picture right there, as I move this, what I'm seeing is, even though it looks like it smears down, everything's lining up. Okay, as I move that. Nothing looks out of place or weird in that reflection like it does here, like there's just some edge here. The idea is with tangents or beyond, we try to eliminate what appears to be an edge as much as possible. Okay, let's see here. Let's see, that there, we imported that. Okay, got that in. Okay, excellent. All right, so blended quarters here. I want to do just a good example of this. So let me find. I hope I brought that one over. Maybe I didn't. Nope. Let me find it here. And oh, that would stink if I. Here we go. Bathtub fillet. That's what I want. Okay, so here is an example of one here. I just want to do a quick demo on kind of that corner setup here. Okay, so let me just get rid of these. Okay, so with normal fillets, this was done, again, maybe we just bring this in as a surface. Okay, imagine this. This is kind of if it was sitting like this, it would be like a pocket in literally like one of those big molded bathtubs. And I look at the way our fillets come into this at the top here, and especially if I turn the edges off. Okay, again, reflection-wise, coming to a point, it's just visually just not quite as appealing. Soft, rounder things is what we're looking for, not sharp, stabby things here. Again, that visual cue. Also, if we get any reflection on it, it'll be called to kind of a strange point. Anytime there's a big point, there's also a bigger stress riser with that. Okay, so what I'm going to do here, let me turn those edges on. Okay, and I'm just going to run through a really quick demo here on how to essentially kind of make this look a little bit nicer here. Okay, so I'm going to start by sketching here. Okay, I'm going to borrow a couple edges here and convert them, connect them up here. Okay, with a spline line. And what I'm going to do here, again, is I'm going to apply what we call equal curvature. So equal curvature is what they call C2 curvature. Okay, it's one of the better curvatures that SOLIDWORKS can use. And what this does is, again, it's more like a spline line. It's not like just a line and a tangent to it. Okay, and what that will do then, okay, is make it so we have, again, a nice, smooth, blended edges. Now, I'm going to take and get rid of the faces that we're not going to use anymore. So I'll do that with a delete face. Okay, kind of open this up. All right, now I'm going to take here, and what I want to do here is trim not only this face down here with the sketch that I created, I also want to take this face and trim it up back to this point. Okay, so we're going to use something called face curves in order to do that. So tools, sketch tools, face curves. Okay, and if I just hit OK, what I would actually do is put a grid on it, but I'm going to put a line here. And what this line can then do is trim, okay, at this point. So I'm going to take here, I'm just going to edit the sketch. I'm actually going to add in one more piece here. Okay, and do a trim. Okay, and now I can take this sketch here and use it to trim. Okay, so we can take a standard here. My trim tool is the sketch, and I will remove this portion. I'm also going to take here and do a trim surface, once again using a sketch for the trim, and remove this portion. Okay, so once again, same concept as what I just taught you, or showed you there before. Sometimes we might need to cut it away, open it up. That way we can come back and blend this all nicely. Now what I'm going to do here is do a right click, select the open loop. Okay, and then what I'm going to do here is do a filled surface. A filled surface is an n-sided surface. Okay, it can be as many edges as you want as long as it's a complete loop. And what I'm going to do here is turn on curvature, okay, with it. So with curvature, I'm going to get as smooth a blend as possible, okay, with it there, and I will say OK. Okay, and now in the end here, I'm just going to go ahead and knit it together. Okay, and I get again a much nicer looking corner there. Again, if I look at it here, now we got again a smoother appearance in that blend. Okay, with that, again, a lot nicer looking than if I drag it back here. This, okay, so from there to there, just again a nicer looking bit. So again, tonight was working with imported geometry. Again, obviously a little bit beforehand and some of it afterwards as far as things that you might do with it. Okay, so now just a few other things here. We talked about some of the surfacing commands just a little bit. Okay, talked about our corner fillets here. One other thing I want to talk about here is this move face command. Okay, this is the true, one of the kind of the grunt work file or tools to work with this imported geometry. So let me take here, close all these. Okay, and I want to pull in that engine again. So let me find back down here. There we go. Oop, nope, that was the bottle. Sorry. Cylinder block, that's what I want, not this one. This one, there we go. Okay, now here's something to know. It's really important here. As soon as this gets done importing, when you do import diagnostics, if you do something in the tree beforehand, you go add a boss, you add material, import diagnostics does not work. Okay? It doesn't turn on. You have to do import diagnostics before you add anything to it. Now, here's another thing. I'm going to run the import diagnostics, okay, to fix this particular part. Now, in the case of that other horseshoe part that we were just looking at, that requires quite an extensive amount of work. Okay, now you're bringing that in and say from, again, that IGES file. You bring it in, you spend a bunch of time repairing it. That file may go up to like 4.5 meg in size. What you can do is File, Save As, push it back to a Parasolid, re-import it, and what you'll find, you'll lose about 75% of the file size. Okay? Now, that usually only happens that very first time that you fix it, you push it out and pull it back in. I think there's overhead. It's in that Steph and IGES file besides not just plain amount of features in a tree that are at work there that kind of get stripped away when you push the Parasolid and bring it back in, that file size drops. Okay, so kind of cool there. Now let me heal this. So again, if there was something extensively wrong with this, I would heal it all, fix it, do anything that I needed to it, and then save it out as a Parasolid and push it back in. Again, we're not losing anything, really, because we're just making that geometry how it was supposed to be in the first place, okay, with some errors. Now, let's take a look. Our last thing here for tonight, move face. Okay, insert, pull down, face, move. Okay, what we can do here, we can do an offset, we can do a translate, and we can rotate. Okay, so let's focus on, for instance, the boss here on this side. Okay, we import this in, and they say, oh, we need to take this face and offset this out an additional 5 millimeters. Okay, and it'll just push that face out. What is this command good for? Not only for dumb imported geometry, or imagine you've got a part that has 300 some features on it, and what you need to modify is like feature number 10. And you know if you change that, there's going to be, because of parent-child relationships, there's going to be all sorts of stuff that I need to manipulate. And in this particular case, this might be easier to use a move face command and add a feature at the end than it is to manipulate that number 10 out of 300. All right, with it there. Other things that we can do here with that move face. Insert, face, move. Okay, once again, we can do an offset. And let's crank it down a little bit here. And take a cylindrical face and bring it in. Okay, or make it bigger. All I have to do is flip the direction. Okay, and we can bring that in. Okay, now, that is, again, that insert, move, face. Let's do another one. Insert, and face, move. Okay, say, for instance, here, I need to take, and this time we're going to do a translate. So I'm going to take a couple faces here, and I want to translate it in a certain direction, and either a 3D sketch here or an edge. And I can take here and move that face over. All right, let's go to 2. Okay, and push that over. So again, this works for, maybe this is a whole wizard. It has, has intelligence to it again, and via location and how things are built, just might not be that easy in order to move it. So great command. Here's the really cool thing about this. Before I do the last option with this, is when I move these things in the realm of an assembly. See, for instance, you've imported this in, you've started bringing this into your assembly, you're mating to this. When you use the move face command, it retains the same address for these faces, meaning you're not going to drop a mate by simply using this move face command, but because when I move this face out, it's the same face address that it was before. Same thing here with the hole. If I had a bolt in here, okay, that was mated to this particular face, simply by shrinking that, it retains that mate. So that's another reason why move face is a really powerful command. Now we'll do one more here. Insert, face, and move. And this time here I'm going to do a rotate. Okay, so I'm going to take this face, and so for instance I need draft or something like that on here. So I'm going to say pick a face. I'll pick an edge to rotate about. Okay, and then I can start either removing. Maybe it needs to just have it cut at an angle now. Okay, again, the key here is the fact that I'm not losing any potential mates. Now, obviously here, if I move this face at an angle, is this, does this particular hole have to be, let's see if this is actually going to do it. And it does. It's kind of hard to see there. Let me see if I can get it just right about there. Okay, the blue was the old one here in the center, and it's moving the whole thing. It's moving that face and this hole 3 degrees. Okay, at that, and we can hit OK. So this face potentially maintains. Oh, now look at that. I forgot to grab that face with it. No big deal. I'll edit the feature, go grab that fillet, and again, it'll push that thing over. So now that hole, it would be normal, okay, to that face. Okay, so let me go ahead and bring this on back here and share. That's all I've got for this session. Again, if you got any more questions, feel free to type it in here while I'm finishing up. Oh, hang on a second. We do have a question here. When exporting a step file, Rick, you might have to type that in one more time there. I cannot can the origin. Oh, I think I know what you mean here. Let's take here. Let's do a file, save as, and let's push this to a step. Okay, and look at it here, and there was, where was it at? It was pushing out as far as with the origin. Oh, okay. So, okay, when exporting the step, I can't change the origin. Okay, so in that particular case, what we would do, say for instance here, let me, in 13 here, they, for some reason in their menus turned off origin. So let me turn origin back on so we can see it. Okay, what I would do if you want to change where the origin is in relation to your particular part, what I would end up doing is a move body command before I did the export. Okay, so I would say insert feature, move, copy. Okay, bodies to move. Okay, here and here. And what I'm going to do then is either via, the easiest way is if I had a sketch point to reference from one place to the other. Okay, with that. So let's see here. If you, well, once I moved it, then via wherever I wanted the origin to exactly be at. Once I did that, then I'd push that out as a step. Okay, at that point. So then you're deciding in SolidWorks where you want that origin to be at. Okay, so next question here. If you have a CNC machine that needs to first use vector graphics before getting into G&M code, what file format from SolidWorks as an export would work best? I have long workaround. That is a great question, and that is something that, Corey, if you can get Richard's email on that, that'll take a little bit more as far as, I think, a little bit more research on our part to find that out. And there's another gentleman that's way more CNC oriented than I am that may be able to better answer that for you. A lot of times, oh, okay, I have added a coordinate system and it works with IGES, okay, but not STEP. Okay. So, well, if IGES are giving you clean models import, I'd stick with that. Okay. Other than that, other than putting that particular, like I said, with move copy where it needs to be, that's what I would do there. So, again, Corey, get that info from him, and then we can follow up with him on that as far as going from him to SolidWorks to his Epilogue laser. And maybe there's some other thing, third party, or something that we can direct him towards, or something we can do in options that would work for that. So I'm not familiar with that particular laser, but we can take a look at that. Okay, let's see here. Okay, good questions there. Very good questions. I like real-world questions like that. Things that, again, that might work there. So, yeah, with that IGES, yeah, it works with IGES, but not STEP. So, like I said, so I'd add your coordinate system, put it to IGES. Also depends. It also sometimes depends on the CNC system that you're using. I know. When I worked at Lazy Boy, we would use Sigma Nest, although we were doing it with 2D parts, essentially. It was plywood, and that would allow you to modify it in the system. And again, depending on 2D versus 3D and that particular system, if you can't manipulate it in one, then we got to come back and push it around here for you to work with. Excellent. Okay, Corey, got anything else from anybody?